Hello everyone, I Ahuti Brahmbhatt, pursuing post-graduation in construction engineering and management from CEP University in the second semester of program studio named Construction Project Execution Monitoring and Control. I have undertaken a project of high-rise residential tower. This group activity includes regular site visit and analyze the ongoing construction project and more emphasis on the execution part of project lifecycle. The portfolio briefly demonstrates few activities undertaken as a part of study, namely project information, then material management, inventory management, tools of quality, application of PIS, and at the last conclusion of all these activities. Firstly, discussing about the project details, it is an ongoing project in Gandhinagar, Gujarat. It's a greenfield residential project of total cost of 160 crores. The site layout for the project as well as the visual representation of the project is shown here. The residential tower comprises of the two tower with the adjoining non-tower area and all have the basement parking, then 3 floors of podium parking and clubhouse in the non-tower area and the 30 floors of residential building in Tower 1 and Tower 2. Total cost of project includes 40% of material cost, 20% of labor cost, 20% of finishes cost and 20% of preliminary expenses. First activity is material management. Material management is one of the most important aspect of execution of project as it is comprised of the 40% of cost of project. Talking about the material store management, layout of the material store is prepared. At the entrance, we have a store manager's office and the storage of material has been done by the categorization named electrical material, plumbing material and safety material. Taking into the consideration the pertaining issues in the store management, 5 years was applied on the material store and some of the suggestions are illustrated. The problems observed on the material store are improper disposal of their packaging material, no provision control for the monitoring, lack of monitoring, manual estimation and lack of inspection checks. Some of the suggestions are provision of waste segregation BIM, material issue counter, checklist and surveillance and BIM and standardized procedures as well as organizing the frequent audits from the head office. Talking about the lead time calculation helps us to understand the minimum time required for the supply of material on the site. For our site, cement, sand, tiles, concrete, TMT bar and AAC blocks are procured from the local vendors, while the electrical material, plumbing material and fire protection systems are procured from the in-house team. For material classification, ABC analysis and HML analysis has been done. ABC analysis is a technique for categorizing inventory item according to their substantial impact on the overall expenditure of organization. From ABC analysis, it can be inferred that reinforcement steel and cement are the A-class material, while admixtures and binding wire are the C-class material. Talking about the HML analysis, it is used to distinguish the materials according to high rate, medium rate, and low rate materials. From this, we can infer that reinforcement steel and binding wire are the high rate material, while aggregate and sand are the low rate materials. The next activity is inventory management. In inventory management, economic order quantity has been calculated, which is defined as optimum order quantity that minimizes the total variable cost of ordering and holding inventory. Calculation of EOQ was done by using the simple classical model. As per the simple classical model, economic order quantity for the reinforcement of steel is 33 metric ton, and if this protocol can be adopted on the site, around 42,000 can be saved annually. The second model we have is a price break model in which different lot size was selected according to their purchase cost. And it can be inferred from the price break model that purchase cost and EOQ have indirect relationship, whereas purchase cost and total cost have direct relationship. And the preferred purchase cost is 64,000 for the lot size of 150 to 180 metric ton steel. Talking about the safety stock and reorder point, it gives an idea about the time when the reorder can be placed. Talking about the first graph, so in the first graph, total stock out cost and the carrying cost are minimized at the safety stock of 9.34 metric ton, which means that optimum level of safety stock is 9.34 metric ton. From the second graph, it can be said that the reorder point is 39.08 tons, which means that when the inventory comes to the level of 39.08 metric ton, reorder can be placed, which will be arrive on the site within the 7 days. The next is shortage model. In this model, shortage are planned to occur leading to back ordering. From the shortage model calculation, the optimum level of 13.48 metric ton should be maintained at the site, which can reach up to 26.95 tons of maximum inventory level. Next activity is quality tools. Quality tools are implemented in the various steps of process in order to define the problems, measure their impact, find out the root causes, and solve this problem to ensure the production of non-defective items. The quality tools which this portfolio describes are control charts, Ishikawa diagram, and histogram. First, talking about the control charts. Control charts are used to observe how process changes over the time. For the calculation of control charts, the observations used are compressive strength of M40 grade concrete cubes. For the X chart, it can be said that three samples are out of limit, where in the R chart, all the samples are within the limit, which is acceptable results. Secondly, histogram. It is used to show the frequency distribution. Here, histogram was prepared for the frequency of water absorption percentage in concrete. Next quality rule is Ishikawa diagram, which is also known as Cousin effect diagram. And the chosen non-conformity for this is tyrolls are not being removed at the time of deshuttering. The causes for this particular non-conformity is human fatigue, concrete hardening, and lack of supervision. The potential causes for this in the terms of 4 M's are described here. So for that, potential causes are unskilled laborers, their material removing, lack of tools, etc. The effect for this is that shear work can be damaged, rework has to be done, and the tie rods are unsuitable for the further use. Last activity for the portfolio is application of 5S. 5S is a Japanese tool which is used for increasing the efficiency and value via application of specific tools. 5S stands for the short, set in order, shine, standardize, and sustain. The scope of work selected for the application of 5S is steel staking yard. Through the visual observation, we are able to analyze the pertinent issues in the steel staking yard, which are two spaces for the scrap disposal, exhausted horizontal spread of space, inefficient storage of steel, unclear spaces for the unloading, no dedicated spaces for the loading, and extra motion for the waste disposal because of the two spaces for the scrap disposal. The current practices of steel staking yard are stacking of steel in bundle without categorizing them according to diameter, inefficient layout and irregular vehicular movement, physical monitoring of stock, projection of requirement on the manual basis by the planning engineer, change in the labor contract due to unavailability of laborers. After the application of bias, few of the suggestions are here. Color coding of bar according to diameter and rollout track should be provided for the vertical storage of steel. Change in the layout, temporary issue counter could be placed, use of BIM software for the tracking, and training of labor and auditing from the head office on the frequent basis. This is the suggested layout for the steel stacking yard. The impacts for this suggested layout are incident spacing for the steel scrap is possible, vertical staking of steel, smooth flow of activities, and storage of steel according to diameter. From the enlisted suggestions, some of the suggestions are possible at this point of time, which are provision of rollout rate, use of BIM software, training of laborers and auditing on the frequent basis, whereas change in the layout of Stylia is not possible at this point of time. And some of the suggestions have a major impact on the resources. In conclusion, this studio of construction project execution monitoring and control gives us the hands-on exposure to a variety of ongoing projects. Quality, safety, contract administration, lean tools, green building analysis are among the topics covered. Aside from that, we use a technological tool like Primavera to keep the track of project. Overall, this studio helps us to understand the project execution concepts better. The key learning from the various deliverables are as follows. First is material management. Material management is an important aspect of any organization as it contributes to the maximum cost of project. ABC analysis and HMI analysis helps us to classify material according to their expenditures, and lean tools helps in the better management of material stored for the easy operations. Talking about the inventory management helps to find out the optimum order quantity required for ordering with the help of simple classical model, price break model. Moreover, the order point provides an idea about the frequency of ordering as well as the lead time of the material for the arriving at site. Third is tools of quality. So quality tools are implemented in the various steps of project to define the problems. Control charts are used to check the variation in the process. Ishikawa diagram helps us to find out the potential causes for the problems, and histogram helps to check the frequency of occurrence. Last is the application of 5S. So 5S is a framework for increasing the efficiency and value by application of specific attitude and tools. It helps us to come up with a suggestion to improve the efficiency of steel taking yard and make it more organized for the smooth operation.